Hi friends, welcome to follow up. Let's have a look at problem 2807. Insert greatest common divisors in linked list. In this video, we're going to present a method based on the strategy of linearly scanning the linked list. So here we can use the math GCD function, or we can write a hyperfunction to compute GCD. So in this problem, we are given the height of a linked list, and each node contains an integer value. So between each pair of adjacent nodes, we want to insert a new node with a value equal to the greatest common divisor of them. So then we want to return the linked list after insertion. So this paragraph explains what's greatest common divisor, also known as GCD. So we're not going to digest here. So here we have two examples. The example 2 is very special because it contains only one node, length 1 linked list. So it just returns itself. And in the first example, we have 18 and 6. So we're going to insert a list node with value 6. And we have 6 and 10. So we're going to insert a list node of value 2, and 10 and 3. So in between, we're going to insert a list node of with value 1. So this is example 1. So in this problem, the constraint is that the number of nodes in the list is in the range given by 1 and 5,000. So 5,000 actually is not a very large number. And the node values are in between 1 and 1,000. So with that said, we are ready to write the code. So here, this actually is a standard operation, right? So we can have a pre which pointing say 18, and then we have a current pointing 6, and then we are going to do the insertion. After we do the insertion, so we shift the two pointers forward. So that's the logic. So first, from the problem assumption, we know the head is not null. So what we want to do is previous is set to be head. Because head is not null, so we can consider its next, right? So then we set these two pointers, and then we can do a standard while loop. While current, so the current is if it's not null. So then we want to insert a node in between previous and the current. So the node value is nothing but the GCD. Let's first use the math GCD function, right? So here we are going to call the previous value and the current value. So with that done, so let's do we have a temp. Let's construct a list node, right? So the value is nothing but GCD. And then what we are going to do to insert, so the insert operation. So it's nothing but we connect previous next to be the temp, and the temp next to be current, right? And then what we are going to do, so you can think of this is the next, this is the temper, this is the current, and then we have this is the previous, this is the next temp, this is the current. So what we want to do is to set previous to be the current, and then current to be previous next, right? Because the condition while current is not null, so we can set this to be pre, and then we can consider the next, right? It still work. So with that said, we are going to return the head. So this is one solution. So here we directly call this method. So now let's do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So you might think that for this version, so we directly use this function in the math module. So now if we actually we can also write our own function based on Euclidean division. So here let's write such a function. So we can use it as a class method or the standard method, or you can use as a let's write a static method. So in other words, it's just a method, generic function. So we can call GCD given m and n. So we can assume m and n are non-negative numbers. See, so here for this problem, we don't need to write that complete. For example, if one of m and n is 0, and then the other will be the GCD, right? So, but here let's assume m is greater than 0, n is greater than 0, right? So if you like, you can also assume it's non-negative, greater than or equal to 0. But that's just the details. Let me comment this out. So here the thing is that, so if m is greater than n, so I'm going to switch them, n and m. So in other words, I'm going to assume m is the smaller one. We will use it as a divisor, and we use n as a dividend. And then what we are going to do, let's first do we are going to use recursion. So first we want to have some base case. First, if m equals 1, and or n is divisible by m. So in this case, so we are going to return m directly. So this is one case. And then we are going to do Euclidean division, right? So we're going to use n and m as a divisor. So then we know that the GCD of m and n equals the GCD of m and the remainder. So what we are going to do is to return self GCD. So we can actually just call GCD m and the r, right? So now in here, what we are going to do, let's comment out this line. Let's comment out, and what we are going to do is call self GCD previous value and current value. Let's still do it in the same job. Now let's do a test. Self is not defined, I see. So here, let's do this. Let me just call solution GCD, and here, yeah, so no self, because we didn't pass any self here. So now let's test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So if you find that this way of writing might be not that easy to manipulate, so you can do something like this. You comment out this, I put it in self, and then here you do self, and then here rather than call the class name, so you can call self, and then this will do the job. Now let's do a test. Yeah, it passes one case. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for this problem. Thank you.